Good evening. Morning. I'm just here connecting to see if my system is currently working. So we're live, and welcome, I suppose. I'm currently in the server on my own at the moment, so today is going to be like a pretty basic explanation of how things are going with the project, to give an update of the progress, and also to quickly do two walkthroughs. One is a random looping of traffic along curves, and the other one is how to scatter and randomize things on and instances on curves to make bridges or brick walls or whatever you need. So let's begin, I suppose. So if you're here and connecting later, thanks for joining, and hopefully you guys are having a good and wonderful December. So today's art is from the Blender Royale that happened on Monday here in the server, and I made this like quick icing on a cake type thing with geometry nodes raycasting. I showed this earlier in a couple of sessions back, but today we're going to focus on this concept here. Actually, I probably should pause. There we go. So basically I have a bunch of drones, and they're flying along these curves, and they're quite a lot of fun actually. They have a little bit of wobbliness, the animation, they're all the same instances, so they just go along each single curve along their flight path, and they do their thing, which is kind of nice. Right now I haven't got a lot of randomization into the curve, just the position, but the animation, maybe I could even like animate the tilt a little bit. The boldiness of the drones, everything along this could be useful for traffic. So that's the first thing that we're going to take a look at. Next thing we're going to take a look at is scattering along the bridge. Hello, Kurumal. How you been?
Great.
Oh, good, I'm glad. Just to let you know, we are streaming live, so feel free to talk. There's nobody connected at the moment, so this is more like a recording for later. But how have you been? Anyway, so I was just talking about this traffic system that I was looking at here, and I'm about to show another scattering system for geometry nodes concerning a bridge system, which is here in my city generation pack. So let me just load that up. So here's my traffic. Let me just show you again in full screen. You can see some drones flying along the some curves. They have some floating animation. They have some tilt. The curves are randomized every cycle. Well, not really. The drones are randomized every cycle, not the paths at the moment, and they just fly along. So this is for my Painterly project for the cyberpunk type city. So it's good fun. It shows some interesting like drone highways, I guess you could say. So that's the first project we're going to take a look at, and then the next project we're going to take a look at this bridge road system. So let me just pull out this plane here, go into rendered view. Oh, it's a bit broken. And I have this bridge with like some strokes, I guess you could say. With let me just make sure the height of the road is not so crazy. Oh, I think I know why. The tower roads instances need to be back into the center of the world. There we go. So this is a Painterly bridge, which is made from artificial intelligence and printed materials, I guess you could say, which is kind of like a walkway or a highway, which I'd be using inside the city. It's a little bit chaotic because I wanted that chaotic vibe. And basically, this is created by using a curve. So if I have this curve on the ground, I can grab like a point and just move it around or extrude it, and it would dynamically regenerate the bridge to however I want. Move it around, maybe even rotate it a bit. And now I have like this footpath system that I can use around the city. And basically, this bridge gives me the power to change the scale of the road, move the pieces up and down or independently, change the width. So it's like a wider road like this. I can make it wider or thinner. I can change the height of the edges so that the edges are like higher, or the height of the whole platform. I can bring it higher or down. And I can change the density of the roadway, I suppose. The seed. And there's a couple of other attributes which I still need to expose inside the tree. But this is like basically, this is where you scatter instances along a curve and work the curve using length. So these are the two things we're going to take a look at today. Is basically how to use instances on curves. Are you guys interested? Hi, Slink, how you doing?
Yes.
Cool. Okay, so let's take a look at the tree. But first things first, how do you guys think this is, how do you, Kura and Slink, think this is done? How are we going to work it through?
Bruh, no idea.
No idea. Which one do you want to look at first?
I'm really bad at geometry notes.
Okay, so I'll try to make it nice and simple for you, yeah? Which one do you want to look at first?
Whichever one you want.
Alright. So my favorite one so far is this little cars. The little cars is a good fun one to take a look at. So I'm gonna go full screen here and just show you basically a breakdown of the entire tree so that you have a general idea of what the tree does, and then I'll break down each part of the tree. So basically what I do, all the green nodes that I have here, these are my input nodes. So the input nodes is basically what the parameters that I have here in the modifier stack, which are here. And then I have basic control curve. So the first things first is we get the control curve and we get the object info at its original position. And then we instance a number of other instances onto that curve, including, and then we randomize its rotation a little bit. So there's a mesh line, which is what I'm using to create the instances with a curve count. So this mesh line is basically a point that I generate with a count, an instance count, and I move it on as the point to instance the curve. So I get the curve, I instance it multiple times. And there we go. From there, I take the curve and randomize the positions of the curve a little bit using a translation and a seed variable. And then I capture the index and realize the instances and change it to an ID, or an index ID, I suppose. So this is important because if we don't do this, the instances on the curves cannot be independentized from different values. So as you can see, I created an attribute from an index, which is this dotted line. The dotted line is now telling me that each single instance has its own index or identification, I guess you could say. So from there, I have to get, I take this information and then I take the information of the curves and I'd use the curve resolution, a nice high number, so it's nice and smooth. And then I use a concept called trimming the curve. So trimming the curve is basically an idea of like you have a start point and an end point of the curve, which means you need to define where the instance is. if we stick the instance to the end of the curve, which would be at the end point of the curve, we can, or at the beginning point, we can kind of define the distance that the instance has traveled on the curve. Then from there, we use this curve information on another instance to points with the actual instance, which is separated children of a collection. And we use this endpoint selection. Endpoint selection is, it drives how many sub-instances we have. So let's take a closer look, I suppose. But at the end of the day, we instance points at the end of a curve, we trim the curve, and we instance multiple curves to drive the traffic. And then we just drive a whole bunch of these orange ones are randomizers, and these purple ones are animation. And this white one's just a visualizer, so we can see the curves. And so at the end of the day, we scale the instances, we translate them, and we do a bunch of different things. So are you ready to see kind of like the connection of the different points? Yeah, is it clear what the basic breakdown is? Or do you want me to go into a deeper aspect?
This is fine.
Oh, good. Okay, cool. So let's go back to the beginning. And let's just disconnect everything, just because we can. So we can only see the curves. So now that we can see the curves, I'm going to just go to the first node. Alright, so this blue one here. So the blue node is basically takes what I mentioned earlier, and it instances the curve by the curve count. So the curve count, I have 18 different curves into a mesh line, which means 18 points. And I instance the curve onto the 18 points. And I use this randomize rotation. So if we take a closer look at the randomize rotation, it's basically you align vector Euler to vector to kind of get the axis that you want to rotate. And I add it to a custom axis so that I can like define its angle. Right now, for some reason, my curve is not facing up, probably because of my alignment. So I just rotated it back around 45 degrees, which is in radians here. Or pi, sorry. Multiples of pi. Division of pi, sorry. And I use this random min-max value. So to make rotation, I usually want to go positive and negative from my min and min, which should be negative and maximum. So I just use subtract by 0 of the value that I want to rotate in the variation. So for example, my rotation variation right now is at 0. But if I decide to turn on my geometry stack. Hey Andromeda, how you doing? So
Hello.
Hello. So let's take a look. I'm here explaining basically a geometry nodes tree. And Loon Qual, hello as well. Welcome. I just noticed you're a Houdini user. Is this? I'm streaming live, but if you want, you can open up your mic. Feel free to talk. This is kind of an interactive presentation. I'm just explaining like this traffic system with geometry nodes and curves. So basically, I've already given a rundown, and now I'm just walking through the tree. And I guess we can I'll show you the end result just to give you guys a bit more context for those who just connected. But basically, it's press play, full screen it, press play. I should probably hide the instance collection. Okay. Control space, press play. I have a couple of drones flying along on a highway with some random animation, random spawning instances. The curves are not that randomized yet, but that's because I wanted them to be kind of like a highway. But basically the drones are just flying around, doing their thing, looping, so I could use this as a looper if I want. And some of them are heavier, some of them are not, some of them are faster, and they have a speed variation to some degree. And they have like this bobbing up and down, kind of like what a drone does when it hits like a thermal or something. And that's basically it, really. This is the concept, to animate along curves. So I have the curve visualizer turned on at the moment, just to see. And this is what I'm explaining. Interesting, I hope. So let's move on. So we're back at randomizing the rotation of the curves, which means if I turn this up, it starts rotating the curves in different directions. So if we take a look here, I'm rotating in Z, so now they're all flying in kind of like a more chaotic fashion, which could be useful for different things. You know, you could have like a predefined flight path, rotate by Z, rotate by X and Y, and then you can have a bit more just with a single path, have a different type of concept to make your drones fly around. So I have that's my randomized rotation on every single instance of this path. And just to let you know about the curve count, this parameter that I have here is basically the mesh line points, which says how many curves do I want working through. So now I like got 53 different instances of drones flying at the same time. If I go into, there you go, so you can see it there. So let's just drop it back down to something like 15. So there we go. And now from there we go back to the concept of randomizing position of curves. And so this is basically the same setup as before. We have a positive and negative but done by the subtract. And I also multiply by the variation and subtract it again to kind of offset it back to the center, and then just translate the instances after I've done the instances. So then we go to the part about the trimming of the curve. So if we pause the animation again, and I'm just going to like basically preview this part and cut this part. So these are my curves. The curves have a set length, I guess you could say, and they all are the same length. So if I randomize the position a little bit, or randomize it's up and down, left and right, or the translation, or put them all to 0. If I put them to 0, they should all line up. So now I have like, I could just do it in one axis, and they will rotate on that particular axis, though my subtraction is making them not line up properly. Let me just mute that. Maybe it is. Oh, it's doing a min and maximum. Oh, that's weird. It's probably because of the random. Okay, I'll probably need to take a look at that later. Should be doing it in only one axis. But now I need to change the position or the size of these curves. So if we split them out again like this, right now I need to use this concept. Let me just break this curve. Was it this one? Oh, what's the hotkey for muting these curves? There we go. So I have the curve here, and we can use the trim curve node to define the end of a curve point and the start of a curve point. So this trim curve node is really handy for this kind of concept. This is exactly what we need. And if we use this with the point instances here, so let's just preview the point instances. Here are the points. You can define using this endpoint selection on the instance points. So what we're doing is we're grabbing the entire length of the curve, and we're selecting the endpoint of the curve as the point for the instance. So those are my drones. They're at the end of the curve, and we use the endpoint selection node to define how many are at the end. And I can even like say I can have them at the start, I can have them along every single point. At the moment the resolution is really high on the curve, so this is instancing a lot of little drones. But I can choose, basically filter the selection of my points to kind of create where the drones are, but I only want the endpoint. So now that we have the endpoint, let me just cut this and use the actual, there we go, little drones. Now I can say, all right, go back to full screen. So after I've captured the attribute, this is for later, but now I can say, all right, I got to use the endpoints of these curves, but not all at the same time. So, hey Reagan and Misael, happy to see you. So here we have a concept of, so I probably should turn Discord down. No. So now I need to like define like a list, I guess you could say, of every single point. So this is where we get the point where we have to capture the integer spline attribute. So an index of every single spline. So here we get the index, which is a dotted line or a diamond, which means it is a field or a group or a list or an array of things. And we take this attribute to drive the identification, the ID of every single seed of a random value. This is how we like define what's happening per instance. So let's go to the beginning, which is my animation controls. So the animation controls that I have here are basically a multiplier, which takes a frame. So in Blender 3.1, you have a new node for capturing the frame data called time, scene time, and frame time. Or you could just use 3.0, and 3.0 can give you get a value node, and you write in hashtag frame to get the frame, and now it's a driver that captures the frame, the current frame, which needs to be refreshed. 1 second. There we go. So now it's refreshed. Whoops. Probably should delete the old driver. There are 2 of them. So pound frame, and then it captures the current frame. Go back to full screen. So I capture the frame, and I'm using this animation control to kind of define the animation variation minimum and maximum. They're multiplied by very low values because I only need a fraction of what these are, and multipliers are quite an efficient node, so don't use divide as much as you can. Try to use multiply. And then from there, I'm using a random value which takes the identification of each single index of the node tree, which I captured here at this particular point in the node execution line, which is the green lines. And I take the random seed, and I use this to multiply the animation. So as the animation progresses, as the numbers increase, it's going to be multiplied by a random value per curve. And this random value, I use it to randomize when the animation starts on the curve. So if we go back down to the point over here with the start and the end point, as you can see, the end point's at 1. So what I'm basically saying is that over time, the animation is going to go forwards at different points per curve, and then hits the end point, and then goes back to 1 again, and repeats per curve, and back to 1 again, and repeats infinitely. So that's the whole entire goal. Hello, Marklin. Welcome. Oh, we got somebody in the chat. So hello, Reagan. Hello, Steve. Feel free to open the mic.
Good evening, ladies and gentlemen.
Good
It's a bit crazy here. It's a bit crazy here in the household, so I might mute myself.
That's no problem. I'm basically
Hello,
just giving a walkthrough, so it's all good.
That's all right. Otherwise, you'll just hear my kids screaming in the background, and it's not pretty.
It's not pretty. That's okay. And the birds, I like it though. It sounds alive.
I don't know if alive would be the word that I would use. Anyway, I'll get into silent mode. If you need me, I'm here.
All right, cool. All right, so let's get back to where we were. So this is my traffic system, and now we need to think about the animation. So if we take a look at a little bit closer at these nodes, we have the randomization of the start times, and then we have the current frame, and we have the animation looping over and over again. So this trim curve concept, as the animation increases, it does like a fraction, or you could do the fraction yourself. But what a fraction does is like, let me just show you. If I search for a math node and I input it here, whoops, I just screwed up my whole entire tree. To put it like in there, move this over. So in the math node, a fraction is basically take any value, any float, so that's 0.001. So let's go take a value. So if it goes to, it goes to 1, right? 0 to 1. And then it keeps increasing. But notice that the fraction, I guess you could say, for example, 6, 7, 8, 9, and then it goes to 0. 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6, 0. And the actual one, the integer, 6, keeps on, is like always increasing. But what a fraction does is it basically tells the number to always be only 1 between 0 and 1. So you can increment, but it will always go 1, 2, 3, and it's a fraction, and then to 1, and then it snaps back to 0. There we go. So this trim curve is doing a fraction practically of the animation value of 0 to 1 practically. So let's take a closer look and press play. And now you can see that when a drone, they're all at random, as you can see, the random value with the seed at the start time randomization has been defined per curve. I have this vary speed thing we'll see later. And I'm doing a fraction, I guess you could say, of the animation value as the frames increase. So you can see here that the frames are increasing constantly in the interface. And it's taking a fraction and making the curve go from 0 to 1 as the animation progresses, and then back to 0 again. So let's go down to 1 curve, for example, and you can see this one spaceship or drone flies to the end, and he's getting there, and he's flying to the end, and he goes back to the beginning again. So that's how we can use a fraction to do 0 to 1 loops, which is kind of handy. So that's what the fraction node or fraction math function does for floats or whatever you need. So that's a good one. Another, just as a side note, before we continue, you can also use ping pong. So ping pong kind of like does the same as a fraction, but just does it in reverse. So if we click on ping pong, 0.2. So it goes through 2 and then it goes backwards. So ping pong is kind of like a reverse moment. As you can see, it's going forwards, backwards, forwards, backwards, forwards. It's the same concept, but it's a lot like it does a similar concept, but just back and forth. So fraction does the loops of 0 to 1, and everything else is okay. So we've got that part of the animation good. We're varying the animation speed by using a module ping pong as well, and a cosine. So as I mentioned earlier, ping pong is kind of like looping the animation. If we change the animation variation to like 20, Yeah, it's a bit too fast. This is the speed of how fast it is. Or just change the strength. As you can see, I have someone at the door. Could you give me one moment?
No.
Oh,
It's
never
his-
mind, it's just a seller.
This is pilot.
Yeah, this pilot's a
The
little bit
pilot's
drunk.
chap. You ready to fly now?
So this pilot is having a hard time. So I just have like at the moment the ping pong is making it go bounce back and forth, and the cosine is notice that ping pong is linear. It goes to 0 to 1 and then immediately bounces back. So I use a cosine to kind of make it smoother. Cosine, if you remember what a sine and a cosine is, these are like just these curves that you can use. I'm using a cosine, so it's ease in, ease out. Cosine is like ease in, ease out. Sine is like practically ease in, pretty much. Or ease out, to remember which. I'm using cosine to ease in and ease out with the speed moments, so that I can then use the seed with a random value, with a minimum maximum of 0 to maximum, to add to the animation variation. So now he's going faster and slower at certain intervals. Yeah, we're just flying through the fog or whatever. And I do this 2 times. I have one here at the bottom. This is for the translation Z. And for example, I can, the minimum and the maximum, I can like control if he's going up and down a lot or not. And drive it. Multiply the time, the ping pong scale, things like that. And this is practically the 2 animation variables that we have. So in the purple nodes, you've got the animation control, multiplier speed, and then the animation variation for the speed variation, and the animation variation for the Z translation, which is also a bouncer. And then from there, how do you align these to curves? So for example, if I mute this node tree and I take a look, and let's just make sure this curve is a little bit shorter so it loops a bit faster. So let me just delete this vertex and delete this vertex too. If we take a look at the drone, he is practically, he's flying, but when he goes around the corner, he doesn't actually rotate, and that's not exactly what I want. So I need to define the rotation on the curve. So in this case, what I need to do is I need to get the normal of the rotation and align the A vector to the normal of the rotation. So this is the up vector, I guess you could say. So my pivot point Z is pointing up on the Y based on the normal vector of that particular thing. So I'm gonna like just put a hotkey to this because I forgot to assign it. Mute and mute this one, and then unmute this cable. There we go. So now I have my up vector, and if I press play, he's now rotating Z based on the Y of the curve. So you can see that at this point here at the end, he's now actually moving down quite nicely. Let's just change the variation. Oops, so that's a bit too fast. So that's the first thing, is like kind of like he's facing up towards the actual curve, which is good. Okay, that's the randomization and the variation. Start time randomization. I need to find a way to multiply this a bit better, the animation multiplier. At the moment it's fixed. So now let's unhide this node, and I get the curve tangent. So these nodes here, these are like get nodes. You get the normal and you get the curve tangent, and we do the same thing. We align the x-axis of the curve of the drone, which is kind of like the forward tilt, I guess you could say. Yeah, tilt forward, tilt backwards. And we take the x-axis and we pivot it to the y of the actual curve. The y is up on the curve. And then I just use a tilt, an extra addition of rotation on the local, just to rotate by a certain amount so that the drone is actually not flat so much, but actually facing forwards. And that's just personal taste, right? You know, like an actual drone. And I could probably, you know, if you're smart enough, you can probably get the curve, angle in world space and then control all of this, but or even like randomize the same animation to drive the speed of the drone. So when he goes faster, it leans forward more. When he goes slower, it goes back. You know, with the same speed generation, if you really want to be super interesting, just for fun, artistic liberties. So I might do this later, but basically that's what you have here. So now from there, we got instance on points because of rotation and scale, but not translation. And we need to instance the index of each instance. So we have, as you recall, we got the collection, which is a whole bunch of these airships we have here. And I can add as many as I want into that collection and we're good. And then I take a random value to kind of between just an arbitrary number. I choose 256, keep it binary. And I take the same attribute that we captured here earlier to define per curve. So it picks a random number based on the identification of the index from the capture node after we've defined the curves and realized their instances, made them real instead of fake. And we get the random value and we put it into the instance index over here. Just kind of nice. And we take another random value of the scale and we do the same with the ID. As you can see, they're both going out there. And we do the same, and from there I just scale all of the instances to a certain like size. So this is this is optional, and this is, I just translate the instances one by one based on the animation here earlier, and that's basically it. So that's my my drone traffic system. So I just need, like, I can define the curve however I want, and I can say, all right, I want like 10 different drones, and I want them all flying in a certain path. I want a little bit of randomization on their trajectory, the same curve in that particular frame in the camera for the city, and I can change like the variation of how fast they're going. So here we go. Oh, I did have it in. Now they're flying a little bit faster. I guess I need to make that multiplier stronger. I can also randomize the location a bit more, but I need to fix this because it's currently broken, and I can change the seed. So hopefully you learned something here. I guess we can go to the next geometry nodes tree that you'd like to take a look at. So what do you guys think? Do you have questions? Do you want me to clarify something, or is it clear? Feel free to open up the microphone if you want. If not, we can move on. So back to the bridge. So this bridge is for my Painterly project. It's basically 3D printed, artificial intelligent walkway bridge, or highway bridge, I guess you could say, where characters could kind of show that they've been animated on them. And basically, let me just make sure that I have a bit more UVs in here. There we go. I can use this bridge to probably tune down the edges there. There we go. So this is my crazy looking bridge that I want to use for the world, decorate the city. And we're going to take a closer look. Hopefully it is interesting so far. So let's go take a closer look at the nodes. So here's the bridge. Here's the node tree. Similar concept where I'm using orange for randomization. In this case, I'm using blue, or I guess you could say purple. or pinkish, pink or orange. Pink is execution or blue. Blue is another layer, pink is another layer. I'm going to use these pink lines to give a clear idea what's happening. The green boxes are kind of like my get data, and this blue box is another level of execution. So here we have 3 levels of execution. One is, we got 3 elements, right? We got the tall towers of the bridge along the curve. We have the spidery sticks split up into 2 layers, and we have the walkway. So 3 pieces. We have the blue layer, the red layer, and the light bluish layer. So that's what we're going to work on. So let's do some muting, and we'll just take a look at the first. Whoops. Welcome back. Alright, so here we have the curve, and if we move the curve around, you can see that everything is aligned, and if we make the curve longer, everything is instanced along the curve. If we delete a point, it will instance away from the curve. Erin talked about this a lot with his bridge tutorial. So it's basically, we take a closer look at just this particular tree. Whoops, full screen it. So first things first, we need to get the curve. Here's the curve, and we get it. So here's the curve object. We get the curve object from exposed in the modifier stack, so we can choose a custom curve down here. So we get the curve first, and we use this node called convert curve to points for instances. Well, no, sorry, it's a different name, but I renamed it something else. But it's basically curve to points. So let's just confirm this. Curve to points. So that's the node that we want, curve to points node, which gives us a count or a length. In this case, we want to use length, which gives us an extra option called the length distance. So the length distance, I have an instance every 3.25 meters. If we increase the number, it increases the distance between the instances, and if I decrease the number, it adds more instances. So I could expose this as a custom variable if I want to. So let's just take note of that for later. I like to use Noodler to get my colors okay, which is nice. And 0 is going to crash me. Nearly crashed. It's good to have like a number. Minimum number usually. So I like to have like a min-max. Or a clamp, I guess you could say. Where you clamp your values just in case you don't want like an issue with crashing. For example, minimum 1 meter, maximum like 100 meters or something like that, and then you can use that there. Or you can do it in your groups here. So if a group, you make a group input node, and I can use this here. But first, yeah, I'll just connect it. It'll go to 0, it might crash me, so I can make a new one. I'm going to call this a float, make it full screen so you can see what's happening. So I'm going to call this the distance, right? Tower distance. The tower distance is going to be up at the top. And the tower density. Oh. Where is the tower density? Oh, it's here in the length. That's the road height. So this is the road density. It's in the wrong name. And the one down below, which is tower distance, I'm going to rename it to tower density. So tower density, I can give a minimum distance of like 1 meter and give a maximum distance of like, I don't know, 512 meters or something like that, 256 meters. And this would be my variable that I can use without issues into length of the curve. So I don't need these anymore. And now the default value is really too low, so I'm going to put it back up to like 3.5 meters. And now it's running a bit smoother. I hope. Whoop, still too dense. Oops, it's going to run really slow because it's instancing too many things. 1 second. The problem with these exposing attributes is that they are overrides. So whatever, like if you make a new tree, it's going to override the settings. And these are kind of like attribute overrides that you want for customization, I suppose. So here we are. And we're currently using convert curve to points, and we go back to instance on points. So this instance on points is really handy for creating stuff from instances, basically. So if you have Erindale's toolkit, you can use a randomize, which I find really handy, or you can just use a random number. In this case, I use a random bias for the hell of it, but I highly recommend getting these add-ons, or the add-on with these nodes. We're good. So same concept where we get the collection, and this collection is gray. Put it back in. And from there we instance the tower collection onto the points that we created from the length of the curve. And we do some random rotation, random scale, just to give us some control, I guess you could say. And then we move on to translating the instances, and then scaling them again after we've instanced them to get a bit more randomization. And that's basically it. It's like taking the curve, taking the length of the curve to points, and then instancing on the points with the collection, and then doing some randomization of the curves and things like that. That's the basic workflow. Those 4 steps. Get your guide curve, turn it into points, instance on the points, and then put out to your execution nodes, the set out nodes. So hopefully that's clear. So if we do that here again, I'm going to take the flat road. The flat road is made of 3 parts. So, oops, Control Alt, right click. So these 3 parts of the road, we have the flat road middle piece, and then we have 2 instances on points for the edges. We have the top edge over here, the instance on points, bottom edge, instance on points, and then we have a rotation Euler to align them. And we also have this scale randomization on all of the pieces. And we have the height of all of the points from the curve. So if you notice here, we have instances on the curve, right? Where we're converting to points. We do the same up here, curve to points, but in this case, we have a different density control. And we transform the points of the curve first, and we transform it by Z. So we get the same curve, but before we do, we get the height that we want from the user interface, which is kind of nice. So this, let's take a look. So now we have the 2 curves, right? We got the bridges with its density, tower density. Now we have a road density with the road pieces, or this could be a lofted curve. It doesn't really matter. It could be anything you want. And we have this road height. So here we have, it's taking the 0 position of the road, and we're transforming it in the Z to go up. Nice and easy. So from there, what we do is we take these points that we've created, and we move them with some randomization on the rotation. We get the instances of the road. We take the position of the sides of the road, where we do some more offsetting. So for example, I have the road width. So I take the road width and I do some subtraction. So make it negative and positive to transform the points yet again to use as the left side of the road and the right side of the road. So if we take a closer look from the top view, I suppose, where is it? Here it is. We can use the road width to define how wide the road should be. And nice. That's all we needed, really. And I think the road's a little bit too thin, I suppose. Scale randomization. Randomize rotations, maybe a bit too much. It's maybe a bit too crazy. Hello. Vera, nice to meet you. Okay. So now we can like define different things. We can scale these instances to however we want. This is the curve, the entire curve. So this is probably not necessary. Road pieces scale. There's just one value. Oh, here we go. Alright, so that's basically the road part. We have a chunk on the left, a chunk on the right, a chunk in the center, and these chunks, one is defined on move to the left, move to the right, and all three of them move up in kind of a chain, I suppose. Randomize my rotation thing for my style, because mine's more like a explosive hand-painterly look. And so from that we have this particular aspect. So now if we hide everything again and unhide these ones, we have my sticks. So the sticks here, this is a very similar concept of where we're instancing on the curve, but it's just a little bit different by how we randomize everything, but it's the same concept where we have instances on where we get the curve over here, and we get the curve data, and we use the curve and the rotation of the curve and everything to drive and align the rotation of these points along the curve, and then rotate them around randomly in X and Y. So there are two groups. So if we take hide one group, we have the horizontal pieces, which are all randomized in a horizontal way, and we have the vertical pieces randomized with certain angles. And none of these parameters are exposed. Oops, hello. But we could technically say change the bias or change the rotation of these sticks to however you want, and change the strength, for example. You know, these could be exposed to define how crazy or not crazy I want these supporting printed sticks from my artificial intelligence to work. So that's basically change the height of it as well, and change the density or whatever I need. Same thing with the length here. I can like define how many pieces or not do I want in the length, and with those two together we can define my crazy looking printed scaffolding, I suppose, or painted scaffolding. I mean, there we go, to support the bridge supports and the other parts. So all of it together, we have the three pieces defined on the roadway, we have the general towers as big supports, and then we have the other actual custom highway supports for my Painterly bridge. And I could draw the curves wherever I want, and since they're all instances, it's kind of nice on the RAM. And we're good. Alright, so questions. What do you guys think? Do you like these ideas? Are they handy? Does it open doors? Or would you like to see the progress of the short film? What do you think, Slink?
Progress, progress, progress.
You want to see the progress? Alright. So let's load up the progress. These are going to be images, because it's like an image-based progress, I suppose. So just give me a moment. But first things first, I I have some other city tools that I've been working on, which is like a skyscraper randomizer system with a height map based on these blocks. This is what I was working on with you guys last week, and basically now it's finished, so I can quickly create a different seed. I also used I studied Ultramesh's city generator to create city blocks. In my city, we have a lot of like boxy houses with floors and things like that. I wanted to mix that in with a sci-fi concept, and I created that too. If we take a closer look, I can show you. Give me a moment. So one of them is called the block instancer. So the block instancer creates basically houses on houses, I suppose. So let's go into my geometry node stack, and I can change the size, the density. Whoa! Probably move it up one by one. There we go. And this is my city block instancer. Yeah. So as you can see, I have like a cluster of instances of skyscrapers, I guess you could say. So these skyscrapers are clustered together onto grids, and they have a particular size, and I can change the height of the buildings in general. Whoops, let me just make sure my view is correct. Put it to like 10 kilometers with one distance. Here we go. So this is basically it. You just have like cities clustered onto grids, and these grids have random rotation that is aligned to the surface of the emission mesh. And you can use this with a weight map to define the height of the center of the mountains by a multiplier. So you can like make the center mountains higher, or sorry, center towers higher or not, and change the random rotation, you know, give it a bit of style, and translate them for even more randomization or whatever. And that's my city center generator. That's all I needed with my painterly effect. The other thing that I have created is my builder, which is the one that I showed earlier with the houses. So right now I have, it's like a Lego block placement system where I have blocks of houses, I guess you could say, which are stacked on top of each other based on a certain height. Oops. So as you can see, it's randomizing, and I can increase the distance between the blocks a little bit, so that there's like, maybe it's 4 meters, maybe 5 meters. There we go. And I can change the scale or the density. Yeah, it's the entire density. But it's basically, what it does is this one's a bit, I need to scale everything a little bit more to actually make it work. There we go. So this is like my city block generator, or like my building generator, which is still a work in progress. But it's nearly done. And it should have like the floor scale, a scatter rotation, random rotation. It also has random scale on the floors, and I can also change the height of the floors. If we go up higher, like some of the floors has like a noise effect going on. So just go up about 130 meters. You can see that some of them have different heights. And this creates my kind of like a quick way to generate kind of an urban sprawl or slum type of look and vibe that I wanted to get with my painterly effect. So that's good progress there. Hopefully I can get some of these rendering tonight. And on top of that, I think I have still a work in progress, but I scatter things on the roofs. It's kind of cool. And I scatter things, randomize things around. And so that's nearly done. So on top of that, I've also managed to work out the traffic system, which was quite an effort. Made some drones, I did some updates to my blog, and on top of that, I also have done a lot of work on the actual workshop and spaceship. So if you take a look here, let me just load up some images. I've been working basically on kitbashing a spaceship and using the painterly effect on it to kind of like remesh the pieces so that they can like be smooth, to kind of get this kind of sci-fi painted look from this robot but onto the spaceship. But I had to design the spaceship silhouette first. So it went through a number of different iterations to get the spaceship design, how I would like it, which is kind of like a converted 3-stage rocket, which is designed to pretty much take off from Earth into space. The boosters, they have their own gliders. The center is kind of like the lunar booster to get into lunar orbit, and the other booster is kind of like a converted freighter, which has its own atmospheric brakes, VTOL, and space controls. And it carries a container on top, a space container for satellites, and it has its own little shuttle. So I designed the whole thing. That's ready to be textured and converted and animated soon, which is great. It doesn't have an interior yet, but for the music video it will. Another thing that I managed to get progress on was the actual workshop for the short video loop. So the video loop is basically a concept where there's a beat from the person who has the music, which is DJ Unknown, which you can see on Twitter and Instagram. And he's planning to release these kind of like environmental loops of what's happening with this particular character in this robot workshop. Hey Lech, how you doing?
Hey,
Hey man.
how is it going? I'm doing all right.
Good. I'm glad. I'm about to wrap up. I'm just giving an update of the short film, actually.
Oh, you're about to wrap up. I missed it again. Why'd I keep missing?
I know. Maybe you hit daylight savings, possibly.
Oh, right. Savings time.
Satan's time.
Yeah, Satan's time.
Yeah, I'm still at UTC, so my time doesn't shift at all.
Ugh, I should just change the time somehow and just never deal with anyone else's time.
Yeah,
Just make it UTC and be done with it.
exactly. Central Standard Time, Universal Time Code.
It's savings time.
But anyway, so since you're here though, this is the workshop that I've been working on. There's a machine part from the spaceship he's working on inside his workshop, and it's filled with robots, and I've designed the workshop. And I mean, I had to optimize the material quite a lot because I was tanking in performance, which was making work not comfortable at all. And there was one point where the material with the 3.0 and the 3.1 update was crashing. It was crashing my GPU. So I had to replace the specular node and actually use the principled BSDF, which dropped my compile times from 7 minutes and a crash to 1 minute, success. And also performance increased. So I had to optimize the material a lot to get that. I also had to optimize the specularity of the material, which means the spots on the actual geometry and things need to be improved. Because if you have a look at these buildings here, for example, I have these like little white spots. There are actually different brush strokes for the actual white spots because I wanted the specular to be painted in. So at the end of the day, I've managed finishing this entire workshop, texturing it, which was very quick and easy. Converted all the geometry from a kitbash, used the asset manager to create the actual concept. I managed to kitbash a whole bunch of CC BY materials, objects and things like that, so that I can actually build things. And now I actually have a workshop. It's got robots. I have a spaceship which I can put to the side, and now I just need the city. So
You're most likely going to continue to run into the optimization bottlenecks.
actually, I have a secret, which is kind of nice. The good thing with this is like the further I zoom out, the less demanding the material is. So I'm far away, the material scales, and I have better performance when things are zoomed out than when I zoom in. When I zoom in, the texture density increases because it's the brush stroke, right? It takes more brush strokes, and I lose performance by zooming in. So in the distance, I don't actually have a performance hit, but up close, I do. And
It's going to
that's
sound really weird, but as you zoom in, your microphone starts to cut out. This is how performance heavy this is, yeah.
yeah, just to give you an idea. So let me just check on my properties. I can change the scale of the UVs, which will decrease the performance. It decreases the quality, but it helps increase the performance to some degree. So that's the only issue, really.
As long as you have a straightforward mechanism to sort of, upscale, downscale sort of thing, you should be good.
Yeah. So I have my
process, right?
Yeah, so for example, some objects, if I don't want to see the brush strokes so detailed, I can change the scale on the fly or with animation, however I want them to be. And then that should be okay. So there we go. That's the progress of the short film so far. And for those of you who are here the whole time and from the beginning, thank you for sticking around. For those of you who joined later, also thank you for joining and listening and also watching. I'm going to wrap this up, but we can hang out a little more later afterwards. So hopefully you learned something. Basically, the curves traffic system and how you can apply animation using fraction or ping pong to create your loops or back and forth along curves using the curve trim node, the trim curve node, sorry, and also how you can capture attributes after you've instanced curves to get individual attributes per curve. And we also learned how you could use randomization to some degree with instances or instance points to create certain geometry and translation and things like that. And that's it. So I'll be here same time, same place next week. I hope you guys have a nice December.
Thank you, you too.
Thanks.
Thank you, mate.
Really?
All right, I'm going to stop the stream here.